Have you ever wondered what makes a computer, well, a computer? It's not magic, it's science. And a huge part of that science is something we call hardware. Think of it like this. If a computer program or an app is like a recipe, the hardware is all the physical stuff you need to make the meal. It's the mixing bowls, the oven, the spoons, and the plates. It's everything you can physically touch, pick up, and, if you're not careful, accidentally drop on the floor. Hardware is the solid, tangible part of any computer system. From the giant servers that run the internet, to the smartphone that fits right in your pocket. It's the collection of electronic and mechanical parts that form the body of the machine, ready to follow instructions. Now let's consider this. Without hardware, software would just be a bunch of ideas floating around with nowhere to go. It would be like having the world's best plan for a treehouse, but no wood, no nails, and no hammer. The hardware provides the stage for the software to perform its incredible acts. It's the screen you look at, the keyboard you type on, and the mouse you click. It's even the little chips and wires hidden inside the case that get warm when the computer is thinking really hard. Every single physical component that helps your computer do its job is part of this amazing family we call hardware. It's the foundation upon which the entire digital world is built. This idea isn't just for big desktop computers either. Your laptop, your tablet, and even your smart TV all have hardware. The screen is hardware. The remote control is hardware. The speakers that blast out the sound for your favorite science show are hardware. It's the physical reality of our digital lives. When you press a button on your game controller, you are interacting directly with a piece of hardware. That piece of hardware then sends a signal to other pieces of hardware inside the console, which all work together to make your character jump on the screen. It's a fantastic chain reaction of physical parts doing their specific jobs. So, to put it simply, hardware is the body of the computer and software is its mind. You absolutely need both for a computer to function. The hardware gives the software a home and the tools it needs to operate, from processing information to showing you the final result. Understanding this distinction is the very first step into the larger, fascinating world of computer science. It's the difference between the physical machine and the instructions that tell that machine what to do. Next time you hold your phone, take a moment to appreciate all the intricate physical parts working together. It's science you can hold in your hand. Let's open up our virtual computer and look at the main parts. First up is the star of the show, the Central Processing Unit, or CPU. Think of the CPU as the computer's brain. It's a small, powerful chip that does almost all of the thinking and calculating. When you ask your computer to do something, like open a program or solve a math problem, the CPU gets to work. It follows instructions from the software and performs billions of calculations every single second. It is the core engine that drives the entire system, making all the decisions and telling the other parts what they need to do. A faster CPU means a faster computer, because its brain can think more quickly. Next, we have memory, which is often called RAM for random access memory. If the CPU is the brain, RAM is the computer's short-term memory. It's like a workbench or a desk. When you are working on a project, you put all the tools and papers you need right there in front of you for easy access. RAM does the same thing for the computer. It holds all the data and instructions that the CPU is actively using right now. The more RAM you have, the more things your computer can work on at the same time without getting slow and confused. But here's the catch: when you turn the computer off, everything on this workbench is erased. That brings us to our third major component: storage. Storage is the computer's long-term memory, like a filing cabinet or a library. This is where you keep all your files, photos, games, and the software itself when you're not using them. Unlike RAM, storage holds onto your information even when the power is turned off. The main storage device is usually a hard disk drive or a solid-state drive. When you save a document or install a new game, you are placing it into the computer's long-term storage, where it will stay safe and sound until you need it again. It's the permanent home for all your digital stuff. Finally, we have the input and output devices, which are often called I/O devices. These are the parts that let you communicate with the computer and let the computer communicate back to you. Input devices send information into the computer. Your keyboard, mouse, microphone, and webcam are all input devices. You use them to give the computer commands or data. Output devices get information out of the computer. Your monitor, speakers, and printer are all output devices. They show you the results of the computer's work, whether it's a picture, a sound, or a printed page. These devices are your bridge to the digital world. So, we have all these amazing parts: the brain, the workbench, the filing cabinet, and the communication tools. But how do they all work together? It's like a beautifully coordinated orchestra, with each part playing its role at the perfect time. Let's say you want to open a photo. You start the process by using an input device. You double-click the photo file with your mouse. That click is an instruction. The mouse sends this instruction signal to the computer, telling it which file you want to open. This is the very first step in a rapid-fire chain of events that happens faster than you can blink. Your simple action kicks off a complex high-speed conversation inside the machine. Once your instruction arrives, the CPU, our computer's brain, takes charge. It figures out what you want to do. Aha! They want to see this specific photo. The CPU then needs to find that photo. It knows the photo is saved in the long-term storage, the hard drive. So the CPU sends a request to the storage drive, asking it to locate and retrieve the photo file. The storage drive searches through its vast library of data, finds the correct file, and makes a copy of it. This process is like a librarian running to the archives to find a specific book that has been requested by a reader. Now, the CPU can't work on the photo directly from the storage drive. That would be too slow. So the copy of the photo file is loaded from the storage drive into the RAM, the computer's high-speed workbench. Placing the data in RAM allows the CPU to access it almost instantly. The CPU can now quickly read the photo data, process it, and prepare it to be displayed. It's like the librarian bringing the book back to the main reading desk where the light is good and the reader can see it clearly. All the active work happens right there, on the RAM workbench, where speed is everything. With the photo data processed and ready, the CPU has one final job. It needs to show you the picture. To do this, it sends the final visual information to an output device, your monitor. The monitor receives this stream of data and translates it into the millions of tiny colored dots, or pixels, that form the image you see on the screen. And voila, your photo appears. All of this, the click, the processing, the data transfer between storage, RAM, and CPU, and the final output happens in a fraction of a second. It's a seamless, high-speed symphony of hardware working in perfect harmony. So why should you care about all this? Why is it important to understand what's going on inside that computer case? Well, for one, it makes you a smarter consumer. When you go to buy a new computer or a smartphone, you'll see a list of specifications: CPU speed, amount of RAM, storage capacity. If you understand what these things do, you can make a much better decision. You'll know that if you like to play a lot of demanding video games, you'll need a powerful CPU and lots of RAM. If you just need a device for writing emails and browsing the web, you can save money by choosing one with more modest parts. It empowers you to get the right tools for the job. Furthermore, understanding hardware can help you troubleshoot problems. Is your computer running incredibly slow? It could be because you have too many programs open at once, which is using up all your RAM. Is your computer telling you that you can't save a new file? You'll know it's because your storage drive is full. Having a basic grasp of how the parts work together helps you diagnose issues and sometimes even fix them yourself. It demystifies the machine and turns you from a passive user into an informed operator. You can speak the language of your computer, which is an incredibly valuable skill in our tech-filled world. This knowledge also sparks curiosity and innovation. Every piece of hardware we use today was invented by someone who understood the fundamental principles and thought, how can we make this better, faster, smaller? The smartphone in your pocket is the result of decades of engineers and scientists working to improve CPUs, storage, and screens. By learning how these things work, you become part of that tradition of innovation. You might even be inspired to think of new ways to use technology or come up with an idea for the next great gadget. Understanding the building blocks is the first step to building something new yourself. Ultimately, we live in a world built on technology. Computers are in our homes, our cars, our schools, and our workplaces. Understanding the hardware that powers them is like understanding how a car engine works or how plants grow. It's a fundamental knowledge about the world around you. It allows you to appreciate the incredible engineering that makes our digital lives possible. and gives you more control over the tools you use every single day. So go ahead, be curious. The science of computer hardware isn't just for engineers, it's for everyone. Consider this.